Okay, so what I want to talk about today um, is explaining binary. I kind of wanted to make a series where I kind of show how to build a calculator from like theory to implementation. And so at the bottom of um, this theory is going to be binary. So I thought it would be a good idea to make like a video explaining this. Okay, so let's just get into it. So first we want to think about how we look at numbers in the everyday sense, right? So when we write down a number, we just kind of think of it as one thing. So like 19 or like 729. But we don't really tend to think of them as addition. But in order to explain like binary, which we want to get to, it's helpful to thinking of our own numbers as just being expressed in addition. All right, so we can think of 19 as 10 plus 9, or 729 as 700 plus 20 plus 9. And what we're doing is we're just adding each place together. So we add the 9 from the 9's place, the 2 from the 10's place, the 7 from the 100's place. So let's just try to formalize what's going on here. So our system that we use every day is called base 10. And the reason it's base 10 is because of this. So if we think of writing down numbers, like a number goes to each of these slots, think of it as this. So this is the 1's place, 10 to 0 is 1. This is the 10's place, 10 to 1 is 10, and so on and so forth. And then we can put 10 numbers here, so right, 0 through 9. So if we want to express something like 4, 8, 5, 7 as addition, this would be like 4 times 10 to the 3 plus 8 times 10 to the 2 plus 5 times 10 to the 1 plus 7 times 10 to the 0. This is exactly what I was just trying to show earlier with that example. This is going to be 4,000 plus 800 plus 50 plus 7. And this is 4,857. So now kind of keeping this on the board, right? What is base 2 or binary? It's when we just have, this is 2 to the 4, 2 to the 3, 2 to the 2, 2 to the 1, right? So our, so I should start this with a 3 instead. 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0. And we can only have two numbers here, so 0 or 1. So let's just try to write something out. So 1, 1, 0, 1. Now what is this? This is going to be 2 to the 3 plus 2 to the 2 plus 2 to the 0. I guess maybe a more explicit way to write this down, to make it kind of match what's up there. 1 times 2 to the 3 plus 1 times 2 to the 2 plus 0 times 2 to the 1 plus 1 times 2 to the 0. So we have 8 plus 4, this is 0, and then plus 1. This will give us 13. And why do we have, like, what is the purpose of binary even being a thing? Well, if we think of what we want to eventually do, build like an electrical machine, like a calculator, that's dealing with like voltage inputs that are only going to be, right, you either have like voltage on or voltage off. You have two different states, and we want to think about these two different states on like the hardware side as binary, because we're going to try to directly implement this idea of working with binary numbers, adding, subtracting them, in order to build our calculator. So let's just do an example of adding two numbers in binary together. So we know that 11 plus 5 is 16. Let's just do a quick example here. So first we want to convert these to binary. And how I like to think about it in my head is like, we just want to think about like powers of 2 that add together to make these numbers, right? So for 11, right, I'm thinking 8 plus 2 plus 1, right? So this is going to be 2 cubed plus 2 to the 1, and then plus 2 to the 0. And then obviously this is really 1 times 2 to the 3 plus 0 times 2 to the 2 plus 1 times 2 to the 1 plus 1 times 2 to the 0. And so if we want to write this in our little like form like this, 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0, right, it's going to be 1, 0, 1, 1. Or we have 1 plus 2 is 3, plus 8 is 11. And then for 5, it's just going to be 2 to the 2 plus 2 to the 0. So think about the same thing right here. This is going to be 1 here, and these ones are going to be off. Okay, now how do we add these? We just add them. We're like here we can put a 6 on there because we can put 0 through 9, but we only have 1 and 0, right? So like what happens if we have like this, right? We can't put a 14 there, so we have to put 4 here, carry the 1. It's the same thing here, right? Because here we're doing 1 plus 1 in binary. Or sorry, 1 plus 1 in, sorry, 2, I'm gonna write 2 in like, just make it with a base 10, is equal to 1, 0, right? This is 2 to the 0, 2 to the 1, right? So 1 plus 1, right? Just like here, we put the thing in this place down here, and now we carry the 1 over. So we're gonna carry this, because like I said, I'm just trying to think of a way to explain this. Like, we don't want to put 14 here. We can only we have to move this slot up here. So same thing, right? We can't put 1, 0 here. We have to move the 1 up here. Same idea. Okay, but it becomes very easy because we're just carrying the same thing over and over. So this becomes like this, and we just keep carrying 0, 1. And now this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 4, which is 16. And that's what we want. So yeah, this was an introduction to binary. And hope this was interesting. I think this series will become way more interesting once we get to actual implementation. And I guess exploring some more theory too, because I want to talk about a little bit about like Boolean algebras and how we can use circuit design from that too, which is pretty cool. But yeah, okay, stay tuned.